Hi, and welcome back. In this video, you will learn about challenges when working with languages. One of the biggest challenges you face with any NLP application is how to deal with various sentence structures. For example, syntax is not consistent for various languages. Some of the most obvious variations include word order. In English, adjectives generally precede the nouns they describe. This is not the case for many other languages, for example, Spanish. Expression of plurals or possession. Possession in English is often indicated by an apostrophe S. For many other languages, possession is indicated by including additional words. Expression of plurals is another factor that changes between languages. Whereas many English words create a plural by simply adding an S, other languages change multiple letters. In the Albanian example you see here, the IN changes to TE with an umlaut. Semantic analysis is the process of analyzing language to extract meaning from text. In order to extract meaning, semantic analysis combines the analysis based on language syntax with a layer that compares semantics across languages. These systems are known as semantic parsers. Developing a statistical model for understanding semantics requires a large dataset of validated translations in the source language. Assembling a dataset for less commonly spoken languages, known as low-resource languages, is a significant challenge for all NLP applications. Vocabulary is another challenge area for working with language. One estimate puts the number of English words in current usage at over 170,000. Other languages have similar word counts or even larger depending on the unit of measure. As you've seen in Module 4, one problem you may need to deal with for your NLP application is words that are not recognized by your working vocabulary. This is known as an out-of-vocabulary or OOV problem. Other challenges include homonyms. There are two different types of homonyms. First, you can encounter homographs, which are two words that are spelled the same but have different pronunciations and meanings, such as, I had to wind my way through the wind. The other form is a homophone, which are two words that sound the same but are spelled differently and also have different meanings, such as, I can only hear you when you are here. Another problem you may run into is false cognates. These are words that sound the same in two languages but have different meanings. For example, sensible in English means reasonable, whereas the word sensible in Spanish means sensitive. There are many examples of false cognates in languages derived from Latin. Finally, some languages such as Turkish and Finnish have very complex morphologies. Morphology in language describes how words are formed by changing either prefixes or suffixes. Both Turkish and Finnish have a relatively small number of base words, which are then turned into a larger vocabulary by adding prefixes and suffixes. While most NLP systems are based on evaluating words or phrases, the best solution to some of the issues you just learned about is to evaluate language at the individual character level. This approach, however, has its own set of problems. The vast array of character sets is a significant problem. For example, the International Organization for Standardization, or ISO, has defined standard encodings for 15 different types of encodings for various alphabets. The Chinese, Japanese, and Korean languages, also known as CJK characters, further complicate character processing. Non-standard spellings is another reason to employ character evaluation. For example, many countries where Arabic is the primary language, there are two different varieties of the language, one standard and one non-standard. This can make evaluating at the word or sentence level quite difficult. Character embedding is very similar to word embedding you learned about in Module 3. With character embedding, each letter in a word is assigned a vector. The model produced by these vectors is then trained to group similar vectors. Here are some common use cases for applying machine learning to language. Using machines to translate between human languages has been a major problem in computer science for many years. In fact, machine translation was one of the earliest goals of computing. Recent advances have made it possible to have real-time translation in some of the most commonly spoken languages. Converting spoken language to a written form has many applications. from medical records to legal or other business settings. Creating subtitles for movies and videos has been greatly streamlined by the advent of machine learning-based transcription services. And finally, the explosion of text-based interactions in recent years has created a major opportunity for business to learn more about their customers as well as their own operations. Capturing and analyzing text is being used for analyzing customer support requests, reviewing and categorizing medical diagnosis, and many other text-based records. In this section, you looked at some of the challenges for working with language. These challenges include problems with understanding context, the wide variety of language structures, and problems resulting from large vocabularies and differences in syntax, and low-resource languages. Finally, you also looked at some of the more common use cases for transcription, translation, and text and voice applications. Thanks for watching. In the next video, you'll learn about 2 different approaches to machine translation.